Good morning, good afternoon, or good evening. This is going to be a full paper walkthrough of the June 2019 2H paper of the new specification. This is going to be attempted to be as much as is possible a blind walkthrough. I have seen some of these questions before, but most of them I'll give my first impressions of and hopefully discuss the best ways to tackle these and the thought processes used, certainly to tackle some of the questions later in the paper. As always, at the start of one of these exams, you just reread the instructions and make sure you're clear on what you're expecting to do. We're using black ink in your exam itself. We're going to attempt every question. We're going to show all the working that's relevant, make sure that it's clear for the examiner. Calculators are used. Make sure it's on, ready next to you. And don't write anything on the formula page. We've got 100 marks, 2 hours. Let's get started. So our first page is our formula sheet. Refer back to it to just double check that you know your formulas. Our first question, however, we have a table showing the heights of sunflowers in a garden centre. We want to work out the estimate for the mean height. Now, mean height, we need the total divided by how many. Well, we have the how many, 48, given in the question. That is also the total, which you can double check, is the total of that frequency column. Now, because our data is grouped, we need an additional column, which is the midpoint. That's what we're estimating. All of these 8 flowers here, we're estimating them to be at a height of 95. Those 12s estimated at 105. The 115 is the midpoint there. 125, 135. Now just be careful. These often do follow some kind of pattern, but don't fall into the trap of expecting the pattern every time. The next step is to calculate a F times midpoint column. So 8 times 95, and this is telling us the total height of those 8 flowers, or the estimated total height of those 8 flowers. 12 times 105 is telling us the estimated height of those. 15 times 115, 10 times 125, and finally 3 lots of 135. Now each of these were the height in that group, so we want the total of this column. That will tell us the estimated total height of all of the flowers, and my calculator's telling me that's 5,400. And now here comes the biggest trap people fall into. Mean is the total out of how many. Now, how many is not the 5 groups, it's the 48 flowers. If you used 5 groups, you would have got an average of about 1,000, and an average of 1,000 is nonsense relative to the question. So my calculator is telling me that's an average of 112.5, and I'm just going to look at the data one more time. 112.5 is somewhere in this group, and that seems to be in the middle of the data. Question 1, done. Question 2, ruler and compass to draw the perpendicular bisector of the line. Now, as I'm doing this on a iPad, I don't have the compass set up, but I'll show roughly what you should do. So put your compass point at D, set some length that's over halfway and draw yourself an arc. Do exactly the same from E with exactly the same compass length. Draw yourself another arc. And then we've got 2 crosses with your ruler. Connect together those 2 points. That there will be a right angle. It will be a bisector. And if you've done this with your pencil and compass and ruler, it will look a lot better. But you at least have to show these construction lines to get those 2 marks. Question 3, set theory. We have our universal set being the numbers from 1 to 10. A appears to be the prime numbers. B appears to be the even numbers except for 2. So explain why A intersect B is, well, that's the empty set. So we simply need to say there are no elements in both A and B. That's exactly what that statement is saying. We'll just put it back in words. We now are picking out an X in the universal set. Remember, universal set was 1 to 10, but X is not in the union. Well, that means X is not in A, and it's also not in B. So which numbers are not in A and not in B? Well, certainly 1 is not in either. And, well, 2, 3, 4, 5, 6, 7, 8 are all in one of them. 9 is the other one, which is in neither. Finally, we have set C. Set C with A and B covers the entire universal set. A intersect C is 2. Well, that tells me that 2 has to be an element. Or let's actually do them in order. So that first statement tells me that, well, anything that's not in A and not in B has to be in C to cover everything. So we have to have that 1 and 9 from the previous part. A intersect C is 2, which means 2 is in both A and C. And it also tells me that the other elements of A, the 3, 5 and 7, are not in C. Finally, B intersect not C, so that's the stuff that's in B that's not in C, is 4, 6 and 10. Well, that means that 8 has to be in C because it's not in C. A nice little double negative there. And really, we should write these in ascending order, but any order is fine as long as we don't put repeats in there. Question 4. A cylinder has a diameter and a height. I always like to have some kind of visual to help me out. We have our 20 centimeter height and we have our 14 centimeter diameter. We want to work out the volume. Now the volume is given to us on that formula page. So either flicking back, or if you've managed to remember it, is pi r squared h. Pi r squared being the area of the base, h being the height. Well, the only difficulty here is making sure that we observe that the radius was not given. We have to halve the diameter to get to that radius. The question tells me to give my answer to 3 sig fig, so I'm going to type in my calculator. I'm going to give the exact answer just so the examiner can see I know what I'm doing. And then the unrounded version, I'm not going to write all the figures down, that's just pointless. And then finally round that to 3 significant figures to put on the answer line. 3080. Question 5. A very wordy question. John buys and sells books for a living. He's going to buy 120 books for £4 each. The way I like to tackle these questions is each time I see part of the wording, I work out the relevant thing. So directly here, this is telling me the total cost is 4 times 120, 480. We're then going to sell half the books. Well, half the books is 60 of them for £5 each. So that's an income of 300. 6 times 5, 60 times 5. 40% of the books. Well, 40% of the books, 120 times 0.4 is 48. So we're selling 48 books at £7 each. Well, that gives me an income, 7 times 48, of 336. So I've got 2 incomes, 1 cost, and then finally the rest of the books. Well, the rest of the books, we've already sold 60, we sold 48. That means there are 12 remaining at £8 each, which is giving me another £96. So I've already built everything I need. So now we want the percentage profit. So let's work out the total income first, which is the 300 for the £5 books, the 336 for the £7, and the 96 for the £8 books. And that gives me that my total income was 732. So then our percentage profit is our profit, which is the difference between our income and the cost, divided by the initial, which is the cost, times by 100. And if we calculate that fraction and multiply it by 100, we get our percentage being 52.5%. Now that gives me some confidence of its correctness, because the question didn't tell us to do any rounding, and this solution came out exactly to 1 dp. So I can have a meta tap on the back for that. Next up, Josh found a book that was worth £15 in 2019. It had increased by 20%. Find the value of the book in 2018. Well, this is a going backwards question. We know in 19, we go back to 18. Well, first up, let's tell the examiner the multiplier. For an increase by 20%, that is a multiplier of 1.2. So if I was going forwards, I multiply by 1.2, but I'm going backwards, so I'm dividing. Be careful not to fall into the trap that the opposite of an increase is a decrease, because it is not, unfortunately. At least not with percentages. So that comes out as 12.5. It is a money, so always put the second decimal place in there. 12.50, £12.50. Double check that makes sense. Yep, it increased in value, so it was cheaper before. Question 6. This immediately looks like similar triangles, and indeed the question does say similar triangles. Our first and main aim every time we see similar triangles is to calculate scale factors. So the first thing I'm going to do is calculate my scale factor. The corresponding sides, the 6 and the 15, match up. So 15 divided by 6 is my scale factor, that's 2.5. I want to find the length of DF, which is this side here. Well, I've just worked out that to get from the small one to the big one, I times by 2.5. So that's 4.2 times by 2.5. In my calculator tells me that DF is 10.5. Again, it's worth just double checking, just having a quick think. Does that seem reasonable? Well, yeah, 6 to 15 is getting bigger. 4.2 to 10.5 is also getting bigger. The next part of the question is asking us to find BC. Well, that's now going from the big one back down to the small one. So instead of multiplying by my scale factor, I'm going to divide. 19.5 divided by 2.5 gives me an answer of 7.8. And again, that seems fairly reasonable. Question 7. This is a reverse mean question. 30 students, the mean mark in the test for the 30 students was that. We have the mean mark for the boys and we want the mean mark for the girls. So there's lots of ways to do this, and I don't normally do this in a table, but sometimes it is helpful. So we have, let's go for the mean, the total for the class, the boys and the girls. So the class mean was 26.8. Well, to get to the total, we can times that by 30. There are 30 children in this class. So in total, the class scored 804 marks. Well, the boys' mean score was 25. But we've been told that there are 13 boys in this group. 25 times 13. The boys scored a total of 325. Well, then the girls score, well, we know the total was 804. So if we subtract the boys' score, we can work out how many marks the girls got, which is 479. But we wanted the mean mark. Well, the mean mark is divided by how many there are. If there are 13 boys, there are 17 girls. So dividing through by that, I'm getting an ugly fraction, but I expected that because the question told me to round. So in here, I'm going to write at least a couple decimal places. And then on my answer line, I'm going to give the rounded version, 28.2. Again, worth double checking. The mean mark was 26.8. The boys' average was lower. So to make that balance, we need the girls' score to be higher than the 26.8, which indeed it was. Question 8. We want to change x kilometers per hour into meters per second. Now I'm going to do this in 2 steps, or actually 3 steps. So I'm going to first go to meters per hour, then I'll go to meters per minute, and then finally to meters per second. Well, a kilometre is quite big, so if I go from a kilometre per hour to meters per hour, I expect a lot of meters per hour. We should know the conversion rate is 1,000. I'm expecting lots and lots of meters, so I'm multiplying. Now from meters per hour to meters per minute, we know the conversion rate is 60 minutes in an hour. However, in a shorter period of time, I expect to have travelled a shorter distance. So this is a division, whereas normally from hours to minutes it's a multiply, but it's the per hour per minute, which causes a bit of a problem. So that's 1,000 over 60 multiplied by x. And then exactly the same logic once again to convert into per second. And then I'm just going to type that fraction into my calculator to simplify it. I could try and simplify it in other ways, but the calculator is here for a reason. 5 over 18x. Question 9, simultaneous equations. So straight away, I'm looking at the coefficients of my x and my y and trying to look for the best way to make them match up. Now I could multiply the top one by 3 and then the x's match up. However, I like using the opposite signs. So if I can make a positive 2y and a negative 2y, then I can just add the 2 equations. So I'm going to multiply that second equation by 2 to create that minus 2y. Well, the top equation I'm going to leave alone, but I am going to bring it over so everything is lined up. And then the y's are the same number but opposite sign, so I need to add the 2 equations. 7x for the x's, the y's cancel as required, equals 15.5. I'm a little worried because that's not a pleasant number, but maybe it is divisible by 7. It's not. So before I move on, I'm just going to double check, and yes, I have made a silly error. I didn't actually double that number on the end. I doubled the 6x, the 3x to the 6x, and the minus y to minus 2y, but I missed doubling the 16 at the end. And that's really good alarm bells to check if you get horrible numbers. You don't need to panic, you just need to double check any silly working. And now I'm slightly happier because 31.5 divided by 7 gives me a much nicer decimal of 4.5. Then I need to go back and find y. Well, I'm going to use the 3x minus y equation because y appears in a slightly simpler way. You can argue that the minus makes it harder, but it doesn't matter which one you use. 3 times 4.5 in my calculator is 13.5. And then finally y is 16 subtract sorry, no, other way around, is 13.5 subtract 16, which is negative 2.5, and there's my solution. A couple of things to point out with this question. Do try and signpost as much as possible what you're planning to do. So I put these arrows here and also this plus here to tell the examiner exactly what I'm doing. It makes it a lot easier for them to mark it. And then the other thing is, if we substituted these back into the original equation, we can know whether we're right or wrong. It's not just a check, it's a guarantee. So if I subbed it back into the first equation, 4.5 plus 2 lots of negative 2.5, that's 4.5, subtract 5 is indeed negative a half, which is what the question wanted. So we know we've got this question right. Not all checking techniques are that guaranteed. Question 10. A straight line graph has a gradient of 5 passing through a coordinate. We see straight line, we think y equals mx plus c. The gradient is the m. The y-intercept, which is given to us, is the c. So we're just writing that answer down once we remember that y equals mx plus c fact. Region R is bounded by 4 straight lines. Now I'm really happy because these straight lines are all horizontal or vertical, which makes the equations very nice. So we're going to write down the equations which define R. So we'll start with that side. Well, that's a vertical line, so that's x equals, so that's x equals 0. And on this side, we have x equals 2. Well, the region R is between those two values. So one of our inequalities is x is between 0 and 2, or 0 is less than or equal to x is less than or equal to 2. The other pair, we have that, which is a horizontal line, so it's y equals a number, y equals 1, and that one is y equals 3. Again, the region R is bounded between them. I was almost about to write 0 again. Is 1 is less than or equal to y is less than or equal to 3. A really nice inequality bounding question there. Question 11, standard form. We have some information about football clubs and attendance. We want to find the difference between the average attendance for Barcelona and Monaco. Well, if we look, that's Barcelona and Monaco. Barcelona's the bigger one. So I'm doing 7.4 times 10 to the 7.7 times 10 to the 4, subtract 9.3 times 10 to the 3. Again, that's a calculator job. The question didn't specify, so I'm allowed to cheat wherever possible. Now the calculator gives my answer as 67,500. The question wants it in standard form. This is where our second mark is coming from. The number between 1 and 10 that's relevant is 6.75, and we move the decimal place 4 places to get to that number. If you are unaware, there is a brilliant button on the calculator which looks like that on the bottom row, which helps you type these in faster, so you can have a play with that button to work out exactly how it works. Antonio says the average for Chelsea is approximately 50 times that for Oxford. Well, let's check that. We're trying to determine whether this is true or not. So I'm going to take Oxford's, that's not Oxford's, that's Chelsea's. I'm going to take Oxford's average and see if I do multiply this by 50, do I get anywhere near the claimed Chelsea's? So I multiplied that by 50. Double checking that I typed it in right. That comes out as 415,000, which in standard form is 4.15 times 10 to the 5. And if I compare that to Chelsea's, that's actually nowhere near Chelsea's, which is only times 10 to the 4. So is Antonio correct? No, he is wrong. And we can even justify further. It is only about 5 times. He was out by an order of magnitude. During last season, the cost of tickets increased by 15%, then decreased by 18%. Now, instead of writing these as separate ones, they want us to write this as one change. Well, an increase by 15% is a multiplier of 1.15. A decrease is a multiplier of 0.92. And if I combine those together, then my multiplier comes out as 1.058. We notice that is an increase, which it doesn't tell us in the question. We know that's in the increase because it's bigger than 1, and the percentage increase is a 5.8. We lose the 1 times by 100 to turn it back into a percentage. Question 12. We have a trapezium and we want the perimeter. Now there's no extra numbers in the question, so all of the information I can use is written right here. So this means I need to find some extra side lengths. I need to find the length of CD and of AD. Well, the nice thing that I've noticed straight away is we have a couple of right angles. So if I instead drop a line down from C, let's call a new point E, then we have a right angle here. And CE is 16.7, carried from the AB. So now we have a right angle triangle where we can calculate CD. So labeling it up, that's our hypotenuse, that's our opposite. I will label the adjacent because we'll need it in a moment. But for this one, we just need the O and the H. Well, that sine theta is opposite over hypotenuse. Sine 43 equals the 16.7 over our unknown hypotenuse, CD. To calculate the CD, we swap it with the sine, and then we're 16.7 over sine 43, which is giving me an answer of 24.486, and that goes on forever. Now my answer wants it correct to 3 sig fig, so in my working I'm going to use at least 2 more significant figures to make sure I don't get any stupid rounding errors. So that was CD. I still need to work out AD. Well, if we look at AD, we can split it into 2 parts. We have AE, which is the same as BC on the top, and then ED is another side of the triangle. Now, we now have both O and H in the triangle. A good hint is to use what's given to you rather than what's been calculated. If somehow you got this answer wrong for CD, you don't want to get the answer to ED wrong as well because you've used that. So I'm going to use the opposite and the adjacent, the opposite being given to us, to try and calculate that last side, and that's a TOA. So tan 43 is a 16.7 over that adjacent side, which is now ED. And again, it's the same trick. We swap the tan and the ED over, and that's going to give me another side length. I'm expecting it to be smaller than the 24.4 we've already calculated, and to be roughly the same as the 16.7. The 43 degrees is very close to 45 degrees being the isosceles angle. And again, I'm going to write down and use at least 3 sig fig in my further calculations. And then finally, the perimeter, we need to make sure that we add up all the correct stuff, but not any extra. In particular, that 16.7 that we wrote in is inside the shape, it's not part of the perimeter. So I'm going to start at A and go clockwise around the shape, telling the examiner exactly which numbers I plan to use. And again, I'm putting the ... in there to be mathematically correct, but not entirely necessary if we're using at least 3 sig fig. And then typing those carefully into my calculator. Another good thing you can do while you're writing these out is to double check that you've got the right number of numbers. This is a 4-sided shape, but we split one of the sides in half, so we should have 5 numbers that we're adding together, and we do. So that is our answer, relatively exact. Again, on the answer line we're going to put the correct answer to 3 sig fig, 99.2. Question 13, cumulative frequency. An easy one, Mark, just to fill out your cumulative frequency. Your running totals versus 7, add on the 10 for the next bit, then add on another 12, add on another 19. Of course, you should check these if you're even slightly unsure. Add another 18, and then add another 14. One thing that they often like to do in the questions is they tell you the total. The total here is 80, and I did get 80 as my final cumulative frequency. So it's highly unlikely that I've made a mistake here. Now we need to try and plot them. This is going to be a bit jarring, swapping backwards and forwards between 2 slides, but I'm sure you'll manage. We have 7, then 17. So at 5, we need to find 7. At 10, we're at 17. We can start at 0 because our first group started at 0. 29, 48. So at 15, we're up at 29. At 20, we're up at 48. 66 and 80. 66 and 80 is at the top of the grid. 80. Now I am just worried that I assumed it went up in 5s, and indeed it is. I got a bit lucky there. I just assumed that it was fairly balanced all the way up. I should have checked those x coordinates. We have all our points, and with a pencil and ruler in real exams you'll be able to draw this curve a lot nicer than I can, and you probably don't want to have that break which I had to do in the middle. Using your graph, find estimate for the median. If I have 80 pieces of data, my median is at 40, so I'm going to pick out 40 and then go down. Again, pencil and ruler in your exam makes this a lot more consistent and a lot easier to keep straight lines straight. But I think that comes out at roughly 17. You do get a bit of leniency. The interquartile range means I need to calculate the upper and lower quartile. Lower quartile as a quarter of the data. Quarter of 80 is 20. So my lower quartile comes out at 12. My upper quartile, 3/4 of the way up to the data, is at 60. This is going to be a very long line, which is going to be very hard to keep straight. But I think that comes out as... Oh, I've been misreading my scale. Yes, I've been terribly misreading the scale. And this is where those lines on the grid, your working lines, are incredibly important for if you do something like this. So I'm going to zoom in a bit further. So this is 15 to 20 is 10 boxes, which goes up in 5. So every 2 boxes counts as 1. So that's 15, 16, 17, 18 and a half for the median. For the lower quartile, it's 2 boxes above 10, so that's 11. And then 20, 21, 22, 23. So then the interquartile range is the difference between these, which is 12. Vectors. At the time of setting this paper, this is not a topic that you've done. I'll do the question anyway. AC is, well, if I want to get from a point A to a point C, and all I really have is another point B. If I wanted to go direct, well, actually I can go to B and then back, or going from A to b is 6 negative 9. Going from b to c is the opposite of going from c to b. So instead of adding, we're subtracting. So that gives me 5 on the top, negative 12 on the bottom. 5, negative 12. Made x the subject of this formula. First problem is that big square root, so let's get rid of that first. Squaring the entire equation gives me a y squared on the left and just the fraction on the right. Now it's a fraction, I don't like fractions, so I'm going to multiply up by the denominator. Now those brackets on the left are essential, that random bracket wasn't, because it's the whole of y squared, which is the whole of x plus 1, which is multiplied by y squared. Expanding that out cleans up the brackets. We want x to be the subject, so we want to try and get all the x's on the same side. Now it's up to you which side you put it on. If I put the x's on the left, I'll notice I'll have double negatives on the right, which isn't quite as nice. So I'm going to send that 2 over and the y squared x back. If I can help it, I don't really want to have negative 2 negative y squared. Next up, let's factorize the right hand side so that x only appears in a single position. And now x is in a single position, we can divide through, and I'm also going to swap the left and right hand sides, divide through to get x equals. Quite a tough version of that question, but at this point in the paper, I'm expecting the questions to be quite tough. Question 16. A huge, well, at least in terms of working space, third question. Show that. Show that means we cannot just type it into our calculator and get the answer. You can use your calculator to guess or predict what will happen, but you do need to show all of your working with no hidden points. The first thing that I'm going to notice is the top is root 8, but the bottom's root 2. Now once you've done enough of these questions, you should notice that root 8 can simplify, and it simplifies to 2 root 2. So from now on, I'm going to use 2 root 2 instead of that root 8. So I am trying to rationalize this fraction. The trick is to multiply the numerator and denominator by the old denominator with the opposite sign. And now we need to simplify that out. On the denominator, it's almost always the easier one, root 2 times root 2, we're just doing FOIL here, plus root 2 minus root 2, minus 1 times positive 1 is a minus 1. I'm also going to simplify that on my next line before I tackle the top. The root 2's cancel, which is exactly what we wanted out of a rationalised denominator. 2 take away 1 is just a 1. On the numerator then, this one's a bit more challenging. We have our 4 times root 2. Our outsides is 4 times 1. Our insides is 2 root 2 times root 2. Well, the 2 root 2 times root 2, the root 2's, if you ever times a root by itself, the rooty bit cancels, so that bit's just a 2. So that's 2 times 2 is a plus 4. And then finally, 2 root 2 times 1 is just 2 root 2. Collecting the like terms on the numerator, 8 plus 6 root 2. We have a divide by 1. Divide by 1 means absolutely nothing. Double check that the answer is in the form we want. It appears it is. The question wanted us to give the value of a. Well, a is a number on its own, and the value of b, which is the number in front of the root 2. So there's our answer. Before we do move on, let's do exactly what I hinted at the beginning of the question. Let's cheat with our calculator, but this time to check our answer. And typing that into the calculator does indeed give 8 plus 6 root 2, but we've shown it rather than calculated it. Question 17, proportionality. This is a nasty one because both your y and your x is in terms of another letter. Well, let's do what we'd always do. Y is directly proportional, y, fish symbol, to the cube of x, so x cubed. The fish symbol we replace with equals k. And then we're going to sub in the given values. Well, y was 20h and x was h cubed. Well, the method continues by finding k. Let's divide by the h cubed, and then notice that the numerator and denominator have a common h, which we can cancel out, leaving 20 over h squared. Well, now's the most important step. We actually need to write down the answer. They wanted a formula for y in terms of x. So I need to write y equals, well, in terms of x and h, y equals, but only with stuff with h's and x's in. So I'm using exactly the line we used up here, but replacing the k with what I now know k is. And that is a formula for y in terms of x. Second part of the question. We now have a different value of y, and we want to find the value of x. We have the formula. So let's substitute in that value of y into the formula that's been given. And now I want this x. Well, let's get rid of the stuff in front. Let's multiply by h squared. Then we get a h cubed on the left hand side. Let's divide by the 20. 67.5 divided by 20 is 27 over 8. H cubed equals x cubed. Well, I don't want x cubed, I want just x. So let's take the cube root. And I was happy when I saw the 27 over 8. This is one of the ones that you'll start to recognize, or you can just type into your calculator. 27 over 8 is the cube of 3 over 2. So cube rooting everything, 27 goes to 3, 8 goes to 2, h cubed goes to h, and that is our x in its simplest form. Once again, the question did say in terms of h, so we weren't expecting a number answer, we were expecting some algebraic. Question 18. Again, this is a question which, at the time of recording this, we haven't done this topic. Maximum value implies that we're going to be using some calculus, some differentiation. Now, even if we don't know that topic yet, we can still get half the marks for finding the formula for the surface area. So surface area of a cuboid, well, we have our front and back being the same, the left and right, top and bottom being the same. So we've got two lots of, well, let's do the front and back first, is x times 2x minus 3, that's our front slash back, plus, and our left and right are exactly the same, 2x, 12 minus 3x, and then the top and bottom are both squares of side lengths x. I need two of them, so that's 2x squared. Let's expand, let's simplify, and we will get an expression for the surface area as 48x, got minus 12 plus 2 minus 10x squared. So that is an expression for the surface area. We want to maximize this. Maximize implies that the derivative of the thing with respect to the variable equals 0. Differentiating that formula, 48x differentiates just to 48, 10x squared differentiates to 20x, bring down the power, reduce the power by 1. Well, if we set that equal to 0, we can try and solve for x. So x is 48 divided by 20, which is 2.4. So the maximum here occurs, well, it's not actually a maximum, it's just a stationary value, but this is a negative quadratic, and we know negative quadratics are the n shape, so its stationary value is a maximum. The maximum value occurs when x is 2.4, but we want the maximum value of a, So we'll sub that back into the formula for A. So 48 times 2.4 minus 10 lots of 2.4 squared. That's a calculator job times 2.4 squared. And we get an answer of 57.6. And that's a maximum volume, maximum value of this surface area as x changes across all of its possible values. Question 19. This immediately screams sine and cosine rule to me. We have the area of the triangle ACD, so that's the right hand triangle, is that, and we want to calculate the area of the entire quadrilateral. Well, it feels like they've already done half the work for us with that, but if we look at the triangle ABC, we have no side lengths in ABC, whereas we know we need 2 side lengths to use half AB sine C. So my aim is to try and find 2 side lengths in ABC. With none, I have to look at the other triangle first. So in ACD, I might be able to find AC by undoing what we thought was a helpful piece of information. And then if I know AC, I can then use sine rule in ABC to find another side. I want to try and make the examiner's life as easy as possible, so I'm going to tell them exactly where I am thinking at any point. So in ACD, I'm going to use the fact that I know the area and I know the formula for the area to try and calculate a missing side. So area was 250, it's half times one of the side lengths times the other side length, which is what we're trying to work out, times the angle between them. So AC, if we undo all that, double, divide by 26, divide by the sine into our calculator, will tell me that missing side as 30.557, and it keeps going. And once again, I'm going to use at least 5 sig fig in these questions because it told me my answer. I want my answer correct to 3 sig fig. I'm going to use 2 more significant figures. And actually looking at it, I'm actually going to make this 558 because I have a couple of 9s after that in my calculator. So that's going to be a pretty good, highly unlikely to make a rounding error at that point. So now I have AC. The point of finding AC was to find another length in the triangle ABC. So I'm going to tell the examiner I'm looking at the triangle ABC. Now I have that pair, which means I can try and find that pair. So that's our sine rule for finding a side. I'm going to use the labels they've given us. C over sine C equals B over sine B. The C is what I want, and that's the side length AB. Little b was this 30.558 over sine of 95, and I've multiplied up by the sine of C to get the AB on its own. I'm also, because it's in my calculator, going to use the answer function, which stores all of the decimal places of that 30.558 rather than just the ones which I've written down. Again, just another way to decrease the chance of getting a rounding error in any final steps. And that comes out as 22.434. And that goes on. The next decimal place was a 0. So again, I'm pretty certain I can't make a mistake with that. Well, remember what our aim was. Our aim was to find the area of the entire triangle. I now have AB and AC, so I need the angle between them. Well, that's an easy little subtract from 180. So 180, take away the 95 to take away the 47 gives that angle there as 38. Again, tell the examiner what you are doing. In ABC, the area is a half. Well, I'm going to change the letters because I'm using that angle at A. So half BC sine A. Doesn't roll off the tongue quite as well. And then plug in the numbers. So that's our 30.558 times the 22.434 times sine of that angle we've just calculated. 0.5 times 30.558 times 22.434 times sine of the angle comes out as 211. And again, I'm going to give a couple more decimal places. Now our question wanted the area of the entire quadrilateral. I've got the area of ABC and we've been told the area of ACD. So now I just need to add those two things up. There is more space on the next page. So our total area is that 211 we've just calculated, 0.29, plus the 250 given in the question, which is 461. Question wanted 3 sig fig, and you can see that I can't have got this wrong. The 3 sig fig is very close to 461. Question 20. Now getting into the meat of the last few questions. The equation of the line is, the equation of the curve is, L and C intersect at 2 points. Well, intersect, when we're talking about graphs, that should immediately bring into the front of our mind there's also simultaneous equations, which the setup of the question lends itself to very easily. Lovely is that the y is already the subject of that formula. So I can sub in y. So sub in, I'm going to sub y equals 9 minus x into the curve C. So x squared minus 3x, that was a y. I'm going to replace it with 9 minus x. Plus 2 lots of, well, it was y squared, but I'm going to write it as 9 minus x squared. Expanding and cleaning up, being very careful with the negative signs. We do have a negative 3x times negative x. Over here, be very careful, that is a double bracket, so do not lose the negative 9x that would appear in the middle. Be careful that it is a positive x squared. Now let's collect together like terms. I'm going to expand the bracket as I do it. I have an x squared, a 3x squared. The bracket gives me another 2x squared. That's a total of 6x squared. I have a minus 27 and another minus 18, which gives me minus 45x. And then finally, 2 lots of... Oh, did I not double? I didn't double my 18. Yeah, this is the point we're trying to do it slightly quickly. We have negative 27 subtract 2 lots of negative 18, which, apologies, is negative 63. Now this is a quadratic. I can try and factorize. One thing I want to notice first is everything is a multiple of 3. So I can divide through by 3 to just simplify the numbers, make the numbers a lot smaller. Now that still doesn't look especially pleasant. And if I do try and factorize this, okay, so I've spotted it, but this is not an easy factorization. If you can't spot factorizations quickly, you can either use the split the middle, or even with split the middle it's quite challenging. You should just use the formula, use the quadratic formula. But I think if we split this into 54 is 9 times, oh, I've got those the wrong way around. 54 is 9 times 6. If I have 2 times 6 to negative 12, and then another minus 9, negative 12 and negative 9 make the negative 21 that I wanted. Of course, quadratic formula is probably better and more consistent there. So we get our two values of x, 9 over 2 and 6. Well, I also want to go back and find my y values. So subbing them back into 9 minus x, 9 minus 9 over 2 is 9 over 2, 9 minus 6 is 3. The answer line has already given it to me in coordinate form, so I'm going to put my coordinates in. And just like the simultaneous equation from earlier in the paper, if we sub them back in and they work in both, then we know we've got it right. We've already checked the line. It's a bit of effort to check the curve, but with a calculator, if you just sub in 4.5, 4.5, and it gets 0, brilliant. If you sub in 6.3 and you get 0, then you know you've got the correct two answers. Question 21. We have a cuboid. We have a ratio of the lengths. And we want to find the angle of AF. My pen just died. There we go. The angle of AF and the base ABC. So if you ever find the angle between the line and the base, then you have to drop that line so it hits the base at a right angle. So the triangle that we actually care about is AFC. The angle we care about is the angle down at A. Well, the problem is we have no side lengths whatsoever. So let's make some up. We're going to make them up so that it matches this ratio. So the easiest way to do it is to say the length of AB we'll say is 4x, the length of BC is 2x, and the length of CF is 3x. Well, now in that triangle, I have one side length. I have FC, but I don't have a second side length. So my first point of attention is to look at that triangle in the base. In the base, we have 2x and 4x. And if I can work out the length of AC, then I can use that AC in this other triangle. Well, this is now Pythagoras. So AC squared equals 2x squared plus 4x squared. Do put those in brackets. Those brackets do matter. 2x squared is a 4x squared. 4x squared is 16x squared. 20x squared. And then when we square root that, we get a root 20. And the x squared goes back down to an x. So I have AC. So now I can go to the triangle which I actually care about, which is AFC. I know FC. I know AC now. And I want to find this angle down here. Again, using our trig, we have the opposite, we have the adjacent. So we're using tan theta is the opposite over adjacent, which is 3x over square root 20. And the x's just cancel. So even though we made up the lines, the lengths of the lines at the beginning, it didn't matter. To get the angle itself, we're going to use the tan inverse to undo the tan. Tan inverse of 3 over root 20 comes out as 33.85. Now we check the rounding. It wanted it to 1 dp. We put on the answer line the 1 dp. Some of you might be worried that I used a unrationalized surd. But if I'm using them in a calculation, not as a final answer, that is fine. Question 21 done. Question 22. That is maybe one of the smallest questions you can ever have. Very simply written, but it's going to require us to do quite a bit of very careful algebra. The hint, whenever you see a simplifying algebraic fraction, is to factorize everything. Now the first thing I notice is in the numerator, each term had a common x. So I'm going to factor out the x first from that numerator. And now I just have a quadratic factor on the top and a quadratic factor on the bottom. I'm going to do the bottom first because I recognise that as a difference of two squares, a 2x plus 5 and a 2x minus 5. Now what that also allows me to do is cheat. The question says to simplify, so there has to be a common factor. So one of those factors in the denominator is going to cancel with one of the factors in the numerator. So either we have a 2x plus 5 or a 2x minus 5. Well, if we think carefully about what those options would be, if it was a 2x plus 5, then our other bracket will need to be a 3x to make the 6x squared and a minus 1 to make the minus 5 at the end. The middle term then is a 15 subtract 2 is the positive 13. So I managed to guess correctly. If I did try the other way round, for argument's sake, if I tried the 2x minus 5, then I would need the 3x, but then I'll need a plus 1. And if I were to expand that out, I get a minus 15 and a positive 2x for the middle term, which is negative 13, which is not what we wanted. Now, of course, you could have split the middle for that. You could have solved the quadratic formula and tried to put them back into brackets. But sometimes a little bit of cheating goes a long way. Now we have our brackets. Two brackets are the same, so they cancel out entirely. And we get to that fraction. Now that can't simplify any further. Don't fall into the trap of trying to cancel the x's, the top x and the x with the 2x. They're not common to everything, so that's actually all we can do. Very little actual content to that question after we get into it. We now have our probability question. We have a bag of sweets which has red and green. We're taking 2 sweets from the bag. Probability of picking exactly one red is 12 over 35, and there are originally 3 sweets in the bag. We want to work out how many green sweets were in the bag. So there's a vital piece of information missing here, which is either the total number of sweets or the number of green sweets. So let's give one of those a letter. I'm going to say let x be the total number of sweets. So now I can start to create myself a tree diagram and put the probabilities in to better visualize this situation. So in each case I'm either picking a red or a green, red, green, red, green. There are 3 red sweets, so the probability of picking a red sweet is 3 out of the total, 3 out of x. But if there's x in total and 3 of them are green, 3 of them are red, then x minus 3 are green. And this also means that the probabilities do indeed add up to 1. Now we're taking 2 sweets, which means we're not replacing. So if we had 3 red sweets at the beginning, we now only have 2 red sweets after we picked a red one. And also the total number of sweets has decreased by 1. The number of green sweets, however, has not changed. It's still x minus 3 out of x minus 1. And again, you can check that the numerators do add up to the denominator, so those probabilities do add up to 1. The final set of branches, we picked a green out, then we still have 3 red sweets out of x minus 1. But we did pick out a green, so we have 1 less green. So it's now x minus 4 over x minus 1. Now which branches led to exactly 1 sweet? We have that version, or that version, red, green, or green, red. So now the probability of 1 red, from our picture, we could take that top branch, remembering we multiply it across the branches, or the bottom branch, and remembering if we take multiple branches, we add those branches. I'm going to do a little bit of simplification here. Collect together the fractions, and you'll notice that these two fractions are identical. That's a feature of the symmetry of the problem. And then collect the two fractions together. The denominators are already equal, so just add the numerators. So that's an algebraic expression for the probability of one red, but the question told us what this answer was. The question told us that this is 12 over 35. So the question is now turned into solve this algebraic fraction equation. Best way to do this is to multiply up by the denominators. I'm going to multiply up by 35. That gets rid of the 35 on the opposite side. I'm also going to multiply up by the x minus 1. That gets rid of the x minus 1 on the left. This is starting to look more and more like a quadratic. It's now a job of expanding everything out, moving everything to the same side, and then trying to solve. So doing that, we now want to make it equal to 0. We also want to make sure that the x squared term stays positive. Negative 12 subtract 210, negative 222, plus 630. I'm also expecting the answer to be a whole number, quite desperately expecting the answer to be a whole number, because remember x in the context of the question was the number of sweets in the bag. I notice that everything's a multiple of 6, so I'm going to divide everything by 6, just like in a previous problem. That's going to make my numbers a lot smaller and just more manageable. Now again, you should probably just go to quadratic formula for this, unless you can spot the factorization. This factorization is sneaky. Is it 105? Is that a multiple of 35? Is 3 lots of 35. Now that doesn't work, because then I'll have a 2 times 3. What else is 105? 105 is 7 times 15. 7 times 15, yeah, that works. So if I need a 7 and a 15. 2 times 15 makes 30, and another negative 7. Again, probably better to use quadratic formula there. So we've got our two potential values of x. However, one of them is completely nonsense. The 7 over 2 doesn't make sense for this problem because x was the number of sweets. But now we have total sweets is 15. So the number green, well, there are 3 red ones, so there are 12 green sweets in total. Maybe not the only way to do this question. You probably could have got to the equation without the tree, but I like drawing the trees. They really help explain the situation. We on to the final question now. So this is functions, which again at the time of recording, this was not a question that had been covered. The function is such that f of x equals 3x minus 2. F of 5 simply means substitute in 5 as the value of x. 15 minus 2, so f of 5 is 13. Next up, our function g of x is defined as so, and we want to express the inverse function in that form. So the technique here is to set y equals the function, and our aim is to rearrange this to x equals. Now this is particularly nasty because x is a quadratic, and rearranging quadratics into x equals is normally incredibly difficult. The only way to do so is actually with complete the square. So I'm going to complete the square on the right hand side so that x only appears in one place. So I'm going to factor out a 2 from the important terms. Within our square bracket, I'm going to now complete the square, halve the value in front of x, subtract off the square of that value. And now I'm slightly happy because the question told me x was greater than or equal to 5, and I can see that 5 appear in that bracket. Expanding out our square brackets, and then cleaning up. And now I have x only appearing in one place, so I can undo all of the layers. I'm going to add that 41 that was subtracted at the end. I'm going to divide by 2. I'm going to square root, and this is where one of the subtleties comes in. Whenever you square root, you get a plus or minus. Now, with functions, you cannot have a choice, and plus or minus is giving you a choice. So here we need to go back to that x is greater than 5 and think what that actually means. If x is bigger than 5, then x minus 5 is greater than or equal to 0. So the right hand side is positive, which means we're going to pick the positive. And therefore x equals 5 plus that root. And I've written it that way round to kind of highlight the fact this almost looks like the quadratic formula, and indeed it really is. And the final step is to rewrite it in the function notation, which involves swapping x to be g inverse and swapping y to be x. And that is the inverse function of that equation. And that is the end of the paper. This will be uploaded into the classes Shobi. Please do use this well. If you do notice any errors or mistakes, please do let me know and I'll endeavour to correct them. Otherwise, thanks for joining me, and I hope that was useful.